Hi, this is Tariq, folks, and this is my assignment 3, I mean. So for part A, image conversion, imported all necessary packages and libraries, got the image from the URL. This is all stuff that you pre-did. And then here, plot the image. This is what the image looks like. Then we get the shape, compare the values, color values, and then here we show the image again, visualize the values inside, so we display all the values. And then here, we created the padded array by adding two rows, 2 columns. Created the kernel, and then we outputted it. Compared both the original and the padded. This is the output. And for this one, we looped through it to apply the kernel array values. Then we plotted it. This is what it looks like. And standard conversion. Here we define a function to squash the values. Here we define the conv2d kernel function. Then here is where we do the line detection. So this one is for the horizontal. Input the values into the array, apply it to the image, and then we show the image based on what we did. Alright. Here we did so up top was the 45. This is top was the horizontal. This is the 45-degree conversion. So here you get the acute, this is the name of the variable, 45 degrees, apply it to the image, and then plot how it looks. And then we did the same thing for 135-degree lines. Applied it, created the kernel, applied it to the image, and now we showed what it would look like. Edge detection here. Basically the same thing as what we did in the first question. So created the kernel, applied it to the image, then showed what the image would look like. And then here did the same thing again. Created the second edge kernel, added it to the image, and then showed what the output would look like. And then here again, did the same thing. Part B, imported all the libraries and packages, loaded the data, loaded the train and test labels, train and test images, normalized it. Here we created the model, and then we compiled it using optimizer, Atom, loss, categorical cross entropy, and then metrics as accuracy. Here we, displayed the summary of it. This is all the layers, different layers. Here we created a custom callback function, or class I should say, to use during the training, so we can output it what the accuracy and we reached was. Here we instantiated it. Now here we're training the model using the train images, train labels, 50 epochs, so we'll do it 50 times. The batch size 256, variable 0. Validation data we use is test images, test labels. Then we use the callback class that we created. Then plotting the results, created a function to do that so we could show the graph. Here's where the graph is. You can see the training accuracy and the validation accuracy. So then to answer these questions, question 3 to 10, did the network present signs of overfitting? Yes, it did. It starts overfitting around here. This is where it starts to overfit. Epoch 10. How many layers were in the model? 5 layers. Layer 1 is the convolution 2D layer. Layer 2 is the max pooling 2D. Layer 3 is the flatten, and then the last 2 layers are 2 dense layers, layer 4 and 5. Explain what the purpose of each layer is. The first layer creates a convolution kernel, helps to produce a tensor of outputs. The second layer, max pooling, is to reduce the spatial dimensions of the output. The third layer is flatten, which is just to take the array of data and convert it into a single dimension. And then the last 2 layers are dense layers that feed data from the previous layer to provide an output based on weights and outputs. Question 6, add 1 or more conversion layers to your model. Okay, so here, create the model. This is the second convolution layer we added. Compile using the same stuff. Trained it. And then plotted the results. It's better than the last model, previous model. So question 7, compare the results. So like I just said, they have similar results, but this model that I just modified has a higher validation accuracy compared to the previous model. Add a dropout layer to the model and rerun it, retrain it. Here, add the dropout layer here. Compiled it using the same settings. Trained it. Displayed the results. Explain in your own words what's the purpose. So the dropout layer is to reduce overfitting of neural networks, and it works by removing the unwanted data. So here, I think I set it to 50%. Yeah, so that was to help with the overfitting. And question 10 is to make another modified again. Change it to 80 this time. The dense layer is different than last time as well. I changed it from 128 to 512. Same stuff, retrained it. And yeah, you can see as I did this, it did get better over the different models. It did kind of fix the overfitting problem, or at least reduced it. And yeah, that's my assignment 3.